Hello everyone, my name is Jiawei Yan and this is my Milestone 2 for Ethermart NoSQL concepts, data distribution strategies, and partitioning implementation. And in Milestone 1, I built a clean, secure relational foundation in MariaDB. And today, I will show how enforced integrity with triggers, scaled queries with partitioning, and why NoSQL and column store matter for growth. So the business challenge we face is Ethermart is growing fast, and we hit 4 pain points. The one is customer reviews are unstructured and hard to analyze with only SQL. And two is product attributes vary a lot, physical gadgets vs digital services. Our Sigma field rigid. And the three is frequent Sigma changes slow down new features and personalization. And for the four is orders, customers, and products are headed to tens of millions of rows. So we need a scalability plan. And that's the context for everything I will demo next. Okay. Oops. In MariaDB triggers, let's do an overview. In this milestone, I implemented 2 trigger groups. The trigger 1 group is to keep orders, the total underscore amount, accurate whenever order underscore items changed. And trigger group 2 is to protect review quality by forcing ratings outside 125 to null. And I will walk through setup and left tests so you can see the result change in the picture. Okay, so for the slide 4 is a demo. This demo is for the trigger 1 setup, but this is only part 1. So first, I prepared the orders table so row ups have a home, and I added the column total amount with a default of 0. And I also created indexes on order data and customer ID. This prepares us for both trigger recalculation and later date partitioning. Now one screen you can see the key DDL for this setup. And the main idea is total live in orders, total amount, and queries is filtered cleanly by date and customer. And for trigger 1 setup part 2, now I set up the actual roll-up triggers on order items. There are 3 events I must cover, which is after insert, after update, and after delete. Each one recomputes the order total with a sum line amount from all items for that order, and that guarantees the number in orders. Total amount is always right. No manual math, no state totals. And you can see an example here for the after insert trigger, update and delete follow the same pattern. So we do a quick test. Let me the trigger 1 in action to show you guys. So the step 1, I insert a new order, so the total start at 0, and you will see the select immediately confirm 0. And step 2, I add an order item for product 101 with quantity 2, and I leave price equal null on purpose. And my before insert logic snapshots product's price into the item, and the after insert trigger rolls up the total. Right after insert, orders the total underscore amount becomes 3200.44. That is 2 times 16,000.22. And for step 3, I update the quantity from 2 to 3. And the after update trigger runs and the total becomes 48,003. Becomes 4800.66. And for step 4, I delete the item. The after delete trigger runs and the total returns to 0. So insert, update, and delete all keep the order total correct without any manual work. And for trigger 2 setup is reviews rating guard. The second trigger group is short but important. Data quality on reviews. I created before insert and before update triggers on the reviews table. If rating is not between 1 and 5, the trigger sets it to null. So that way, dashboards or sentiment analysis never get poisoned by illegal scores. So on screen is the compact trigger definition for insert. Update is the same rule. And now let's test the trigger 2 if it's invalid or valid. So for the first test, I insert a review with rating equals 0, and immediately after I select it and the stored value is null. The trigger blocked the bad rating. And for the other test, I insert another review with rating equal 5. Now the selector shows 5 because it is valid. This confirms the guard works for both invalid and valid cases, right at the boundary where data enters. And for the NoSQL concepts, YCAP document, so triggers protect integrity, but they don't solve flexibility or scale for unstructured data. That's where NoSQL helps. So why NoSQL? Flexible sigmas, horizontal scale, and high throughput for fast changing data. And the CAP theorem, in a partition, you must trade between consistency and availability while tolerating partitions. For reviews, an AP choice, high availability with eventual consistency can be accessible. And key value feeds sessions, shopping carts, and fast counters. And document feeds reviews and dynamic product attributes. For Ethermart, I keep transactions in MariaDB and find out reviews and flexible attributes to a document store so we can add fields without sigma migrations. And for the data partitioning, after triggers, the next milestone task was partitioning. Partitioning breaks a very large table into smaller logical pieces. But queries still treat it as one table. For Ethermart, the orders table is projected to hit tens of millions of rows. That's why I choose range partitioning on order date. This way, each year goes into its own partition, making queries and lifecycle management much easier. Okay, so here's the setup. First, I created a shadow table called orders_p. Its primary key includes both order ID and order data, or order date, because MariaDB requires the partition key in the primary key, and I defined 3 partitions. So one for all dates before 2024, and one for 2024, and a max partition for everything in the future. Then I copied all rows from the original orders into orders_p. Finally, I swapped the names to so orders_p became the live orders. At this point, the table looks the same to applications, but behind the screens, the census is physically split into yearly chunks. So let's do a test. I run an explain partitions query for all orders in June 2024. The output shows that MariaDB only touched the P2024 partition, not 2023 or the future. That's called partition pre-running. It means queries automatically ignore irrelevant data, saving time and resources. Operationally, this also makes archiving easier. So like I can drop the 2023 partition when it's no longer needed, while keeping 2024 and future data fast for transactions. Okay. And for the MariaDB column store, so MariaDB column store is column oriented and built for analytics. So by storing data by column, it archives very good. Compression and fast aggregations. Perfect for big scans, and it also supports distributed MPP execution for scale. I would keep InnoDB for OLTP, orders and transactions, and offload heavy analytics like reviews, sentiment trends, or sales roll-ups to column store. And that pairing gives us both correctness for transactions and speed for the analysis. So at the end, I do a reflection on the AI use. I will be transparent about AI in my workflow. Tools I used ChatGPT to draft the SQL, design the trigger patterns, and sketch my slide outline. And specific corrections and refinements I made with AI is help. I corrected a column mismatch in my trigger from price per unit to the real price column in order items. And then I added orders total amount before building the roll-up logic. I tightened validation quantity must be bigger than 0, so we never compute nonsense totals. And I structured the demo steps so you can see a clear 0.0 to 3200.44 to 4800.66 to 0 story. And the benefit is faster iteration, step-by-step guidance, and fewer mistakes. So I could focus on architecture and testing. And the limitation is I think AI doesn't execute in my environment. I validated everything myself. Some suggestions were generic and I adapted them to my Sigma data. And for the impact, I think like combining AI assistance with my own verification made this milestone faster, cleaner, and more reliable. And that's how triggers, partitioning, NoSQL, and column store prepare scale. So thank you for your listening.